Welcome to the AWS Certified Cloud Practitioner Prepcast, where we guide you through everything you need to know for your certification exam. Whether you're just starting or looking to refine your knowledge, this course will set you up for success. Brought to you by baremetalcyber.com. Let's get started. Monitoring is one of those invisible yet critical disciplines in cloud computing. Without it, teams are left guessing whether their applications are healthy or their infrastructure is performing as expected. Amazon CloudWatch is the service that pulls together all the key signals in AWS metrics, logs, alarms, and dashboards. Think of it as a central command center where you can see what's happening, detect when something goes wrong, and act quickly. For learners, it's important to understand that CloudWatch is not just about numbers on a screen. It's about unifying different kinds of information, performance data, system messages, and visual dashboards, so administrators and developers can make informed decisions in real time. At its core, CloudWatch revolves around metrics, which are simply numerical measurements describing how a resource is behaving. For example, the CPU usage of a server, the number of requests to a web application, or the amount of free storage space. Metrics are organized into namespaces, which act like folders grouping related measurements, and dimensions, which provide context like, this metric belongs to this server in this region. Understanding namespaces and dimensions helps you filter and organize data meaningfully, so you can zoom in on what matters instead of drowning in raw numbers. This structure is the foundation for everything else CloudWatch provides. CloudWatch automatically supplies many metrics for AWS services, but sometimes you need your own. That's where the distinction between standard and custom metrics comes in. Standard metrics are built in, like CPU utilization for Amazon EC2 or request counts for Amazon S3. Custom metrics are those you define and publish, perhaps tracking the number of orders in an e-commerce app or the processing time of a batch job. Both types are essential. Standard metrics give you coverage out of the box, while custom metrics let you tailor monitoring to your specific business needs. Beginners should see this flexibility as empowering. You're not limited to what AWS decides is important. Metrics become powerful when paired with alarms. An alarm is a rule that watches a metric and notifies you when it crosses a threshold. For example, if CPU usage goes above 80% for more than 5 minutes, CloudWatch can send an alert. Alarms help turn raw data into actionable signals. Instead of checking dashboards constantly, you let the system watch for you and only raise a hand when attention is needed. This is similar to a smoke detector in your home. It continuously monitors the air and only makes noise when something's wrong. Alarms automate awareness, reducing reliance on manual checks. Dashboards provide the visual layer of CloudWatch. They allow you to build panels that display key metrics, alarms, and logs in one place, making it easier to see trends and spot anomalies. A dashboard might show system health across multiple regions or compare performance between applications. For new learners, dashboards are the bridge between technical detail and human understanding. Instead of interpreting streams of numbers, you can glance at a chart or graph and immediately see whether things are normal. It's like a car's instrument cluster. A quick glance tells you if the engine is overheating or the fuel is low. In addition to metrics, CloudWatch ingests logs, which are textual records of events. Logs might include system messages, error reports, or application-specific output. By centralizing these in CloudWatch logs, you can search, store, and analyze them without juggling multiple tools. Retention policies let you control how long logs are kept, balancing historical visibility with storage costs. Beginners should recognize that logs complement metrics. While metrics show what is happening in numbers, logs explain why with details. Together, they provide a richer picture of system behavior. To make sense of logs, CloudWatch offers Logs Insights, a query engine that lets you search and analyze log data efficiently. With Logs Insights, you can run queries like show me all error messages in the last hour or count how many times this function failed today. This saves time compared to manually combing through files. For example, When troubleshooting a sudden spike in errors, Logs Insights helps you zero in on the root cause quickly. Think of it as having a powerful searchlight in a dark archive room. Instead of opening every box, you ask specific questions and get immediate answers. While many AWS services report metrics automatically, sometimes you need direct visibility into your servers or even on-premises machines. The CloudWatch agent provides this capability. Installed on an EC2 instance or a physical server, it collects system-level metrics like memory usage, disk performance, and custom application data. This agent bridges the gap between AWS-managed visibility and the real details inside your workloads. It allows CloudWatch to monitor not just what AWS can see from the outside, but also what is happening deep inside the system. For learners, the CloudWatch agent is key to extending monitoring beyond the basics. Logs themselves can be structured so that CloudWatch can treat them like metrics. This is where the embedded metric format comes in. It allows developers to include metric information directly inside log events. For example, a log entry might include details like order count equals 250 inches or response time equals 120 milliseconds. CloudWatch then interprets those as metrics, giving you the ability to graph and alarm on them just like built-in measures. This blurs the line between logs and metrics, creating a flexible way to capture custom insights. Beginners should appreciate that this lets you design monitoring around business outcomes, not just infrastructure performance. Another advanced feature is anomaly detection, which uses machine learning models to understand what normal looks like for a metric. Instead of manually guessing a threshold, anomaly detection learns from historical patterns and raises alerts only when behavior deviates significantly. For instance, if traffic to a website normally doubles on weekends, anomaly detection will recognize that as normal but still flag unexpected spikes or drops. This reduces false alarms and helps teams focus on real issues. Think of it like a thermostat that learns your daily habits, adjusting itself intelligently rather than relying on rigid settings. CloudWatch also provides a synthetic monitoring feature called canaries. These are small scripts that run on a schedule to test endpoints, such as websites or APIs from different locations. If the canary detects that a site is slow or unavailable, it reports back to CloudWatch. This is like hiring someone to check every few minutes that your store doors are open and the lights are on. For learners, canaries highlight the importance of proactively testing availability, not just waiting for users to complain that something is broken. For more complex applications, CloudWatch Application Insights can automatically detect common issues. It uses built-in knowledge to spot patterns like memory leaks, failed connections, or latency spikes. Instead of requiring manual setup, it provides pre-configured insights for popular workloads like Microsoft SQL Server or .NET applications. Beginners should see this as a shortcut. It helps surface likely problems without needing deep expertise in every technology stack. By automating detection, Application Insights accelerates troubleshooting and reduces the time systems remain degraded. CloudWatch also integrates with EventBridge, a service formerly known as CloudWatch Events. EventBridge allows events from CloudWatch Alarms or other AWS services to trigger actions. For example, a failed login attempt could trigger a workflow that disables the account, or an alarm could notify a team via chat. This connection turns monitoring from passive observation into active response. It closes the loop between detecting an issue and taking corrective action. Learners should understand that this is how monitoring becomes automation, reducing delays between problems and fixes. Finally, it's essential to be cost-aware with CloudWatch. Every metric, log, or dashboard stored comes with a price tag. Storing months of detailed logs or publishing thousands of custom metrics can add up quickly. Teams should design monitoring strategies that balance visibility with budget, using retention policies and targeted metrics to focus on what matters most. A practical analogy is home security. You don't put cameras inside every drawer, but you do cover the doors, windows, and safes. Beginners should remember that effective monitoring isn't about collecting everything, but about collecting wisely. For more cyber-related content and books, please check out cyberauthor.me. Also, there are other prepcasts on cybersecurity and more at baremetalcyber.com. One of the challenges in monitoring is dealing with alert fatigue. If alarms are too sensitive, teams can drown in notifications and start ignoring them. CloudWatch helps address this with composite alarms, which combine multiple conditions into a single trigger. For example, instead of raising an alert every time CPU usage spikes briefly, you might configure a composite alarm that only fires if high CPU and high memory usage occur together for more than 10 minutes. This reduces noise and ensures that alerts carry real meaning. For learners, it is helpful to see composite alarms as filters that highlight true problems rather than false alarms. Another valuable tool is metric math, which lets you perform calculations directly on metrics. This can reveal deeper insights than raw values alone. For example, you might calculate the average error rate per request by dividing error counts by total requests, or estimate costs by multiplying usage metrics by pricing rates. Metric math transforms simple measurements into actionable indicators. Beginners should think of this as similar to using formulas in a spreadsheet. The numbers are more useful once you combine and analyze them. This capability allows CloudWatch to move beyond displaying metrics to deriving intelligence from them. Alarms in CloudWatch can also drive automated scaling. When resource usage crosses thresholds, CloudWatch can trigger auto-scaling policies to add or remove capacity. For instance, if CPU usage stays high, new EC2 instances can be launched automatically to share the load. If usage drops, unneeded instances can be terminated to save costs. This closes the loop between monitoring and action, ensuring systems adapt dynamically rather than relying on manual intervention. For beginners, this is one of the clearest examples of how monitoring translates directly into operational efficiency and resilience. CloudWatch is often described as part of the observability triad: metrics, logs, and traces. While CloudWatch handles metrics and logs, AWS X-Ray provides tracing, which shows the journey of individual requests through complex applications. For example, a single user request might travel through multiple services: a web server, a database, and a messaging queue. X-Ray tracks this path, revealing bottlenecks or errors. Together, these three pillars give a complete picture of system health. Learners should view observability as moving from snapshots of performance to full stories about how systems behave end-to-end. Different AWS services provide specific telemetry that integrates with CloudWatch. For container platforms like Elastic Container Service and Elastic Kubernetes Service, CloudWatch can monitor cluster health, task performance, and resource usage. For AWS Lambda, the serverless compute service, it tracks invocation counts, errors, and durations. Each service has its own relevant signals, and CloudWatch acts as the unifying lens to bring them together. This ensures that no matter what technology stack you use, from containers to functions, monitoring remains consistent. Beginners should see this as reassurance. CloudWatch adapts to many service types without requiring separate tools. In larger organizations, visibility often extends beyond one account. CloudWatch supports cross-account dashboards and sharing, allowing a centralized operations team to view and manage metrics across multiple business units. This is particularly useful in multi-account strategies where development, production, and testing environments are isolated. Instead of juggling multiple dashboards, one unified view makes oversight practical. Imagine a hospital monitoring patient data across different departments. Centralizing dashboards ensures coordination. For learners, the takeaway is that CloudWatch scales to organizational complexity, not just individual accounts. Retention policies are another critical element of CloudWatch strategy. By default, metrics and logs can be kept indefinitely, but storing everything forever is costly and often unnecessary. CloudWatch allows you to define retention by data tier, meaning you can keep high-resolution data for a short period, then downsample or delete it later. For example, you might keep minute-by-minute metrics for 2 weeks, then hourly averages for a year. This approach balances detail for troubleshooting with efficiency for long-term analysis. Beginners should recognize that thoughtful retention policies protect budgets while still supporting operational needs. When an alarm fires, it needs to reach the right people quickly. CloudWatch integrates with Amazon's simple notification service to send alerts by email, SMS, or to applications like Slack in a ChatOps model. This routing ensures that issues do not just appear on a dashboard, but land directly in front of those who can act. Teams can even set different channels based on severity, such as paging on-call engineers for critical issues but emailing weekly summaries for less urgent trends. This level of integration turns CloudWatch into an active participant in communication flows, not just a passive reporter. Linking alarms to runbooks further enhances response. A runbook is a documented set of steps for handling a specific issue, such as restarting a service or scaling up resources. CloudWatch alarms can be configured to not only notify teams but also reference or trigger runbooks. This shortens the gap between detection and resolution, reducing downtime. Think of it as pairing a fire alarm with instructions for using the extinguisher. Beginners should see that automation is not about replacing humans, but about equipping them with the right playbook at the right moment. Governance is often overlooked but critical in monitoring. Without naming conventions or severity levels, dashboards and alarms can become chaotic. CloudWatch allows organizations to enforce consistent structures, such as prefixing alarms with critical or categorizing by team. This makes it easier to manage at scale and ensures everyone interprets alerts correctly. For example, a critical database alarm immediately conveys urgency and scope. Beginners should recognize that monitoring is not just technical configuration, but also disciplined process design, ensuring clarity and accountability. For those preparing for exams or real-world interviews, it is important to distinguish CloudWatch from CloudTrail. Both are logging-related services, but they serve different purposes. CloudWatch focuses on performance and operational telemetry, answering, "How is the system behaving right now?" CloudTrail, on the other hand, captures API calls for auditing and forensic investigation, answering who did what and when. Mixing the two can cause confusion, but together they form a complementary picture. For learners, remembering this contrast helps prevent misunderstandings and clarifies the role of each service in AWS security and monitoring. Effective monitoring requires continuous tuning. Thresholds that worked last year may not reflect current workloads. As systems evolve, teams need to adjust alarm settings, update dashboards, and refine signals to avoid both false alarms and blind spots. This iterative process is much like maintaining a musical instrument. It needs periodic tuning to stay in harmony. Beginners should see monitoring not as a one-time setup, but as an ongoing discipline, adapting with the business and technology landscape. CloudWatch also supports moving from simple monitoring to formal service-level objectives, or SLOs. An SLO is a target for reliability such as 99.9% uptime over a month. By defining SLOs, teams align monitoring with business goals rather than arbitrary numbers. CloudWatch metrics and alarms then become tools to measure and enforce those commitments. For example, error rates and response times can be tracked against SLOs, giving teams confidence that they are delivering the promised quality of service. Learners should view this as the ultimate goal of monitoring, turning telemetry into measurable reliability. At its heart, CloudWatch is about transforming raw signals into actionable intelligence. It reduces noise with composite alarms, extracts deeper insights with metric math, and enables automatic scaling in response to demand. It ties together metrics, logs, and traces into a coherent observability strategy, while adapting to diverse workloads from containers to serverless functions. It also ensures that the right people are notified, supported by runbooks and governance practices. Beginners should see CloudWatch as not just a monitoring tool, but as a framework for building reliable, resilient systems that can evolve over time. In conclusion, CloudWatch embodies the principle that data without action is useless. It captures performance metrics, ingests logs, and provides visualization through dashboards, but its true value lies in enabling alarms, automations, and service-level accountability. For organizations, it turns streams of telemetry into confident decision-making. For learners, it offers a clear path from basic awareness to advanced observability practices. Just as a pilot relies on instruments to fly safely, cloud teams rely on CloudWatch to steer their systems with precision and trust. That concludes today's episode of the AWS Certified Cloud Practitioner Prepcast. Be sure to tune in for the next episode and visit us online at baremetalcyber.com or cyberauthor.me for more resources, including news, mailing lists, YouTube videos, podcasts, and much more.